Hello, future Boilermakers, and welcome. This is the live Q&A broadcast for several majors in the School of Engineering Technology here at Purdue University, specifically majors within our Manufacturing Engineering Technology and Mechanical Engineering Technology programs. Congratulations on being admitted here to Purdue, and we're glad to have you and your family with us tonight. My name is Alex Rodriguez, and I'm a junior in Mechanical Engineering Technology. I'm originally from Indianapolis, Indiana, and of our panelists tonight will include professors, academic advisors, and current students, and we'll get to meet everyone a little later here shortly. The six majors that we'll discuss tonight will include our automations and systems integration major, mechanical, mechatronics, and robotics engineering technology majors, as well as our digital enterprise systems and smart manufacturing industrial informatics majors. In a different broadcast 2 weeks ago, we covered majors in our electrical engineering and industrial engineering technology programs. And if you're interested in these programs, please go to the web address on your screen to see a replay. You guys can submit questions via the YouTube chat window by signing into your Google account and typing them in. Diane Razel, as well as our technical director, John O'Malley, will be monitoring the chat to answer any questions and pass them along to me. If we don't get to your question tonight, please feel free to send a follow email to techrecruit@purdue.edu, and we will respond to them a little later on. Before we get into our discussion, I'd like to ask the professors here to introduce themselves and tell us each a bit about what they teach. Good evening, Professor Burbank. Let's start with you. You're muted, Professor.
Good evening, everybody. So I'm Ken Burbank. I'm the head for the School of Engineering Technology, and I'm very glad you're all here tonight.
Professor Hartman, could you also introduce yourself?
Sure. Good evening, everybody. My name is Nate Hartman. I'm a professor in manufacturing engineering technology. The areas that I work in have to do with digital enterprise systems and smart manufacturing.
Professor Garcia.
Hello, everyone. My name is Jose Garcia. I'm an associate professor in the School of Engineering Technology on the Mechanical Engineering Technology program. And my area of expertise is in fluid power. Anything that has to do with hydraulics and pneumatics are the classes that I teach in the research also.
Definitely a fun class. Professor Newell.
Hello, I'm Brittany Newell. I'm an associate professor in the School of Engineering Technology on the mechanical side. I teach the Gateway freshman incoming course, and I do research on embedded sensors and actuators and 3D printing.
And Professor Fuerst.
Hello, welcome tonight. I'm Travis Fuerst. I'm an assistant professor of practice in manufacturing engineering technology, focused in the digital enterprise systems. I focus in the PDM, product lifecycle management, all your three-letter acronyms, ERP systems, all that goodness.
An academic advisor within the School of Engineering Technology is also here with us. Good evening, Susan. Would you please introduce yourself?
Good evening. I am Susan Hockings. I'm a senior academic advisor in the School of Engineering Technology. I've been in advising at Purdue and in the School of Engineering Technology for 8 years.
Along with our professors, we have a couple student panelists here, and I'd like for each of them to introduce themselves. First, we have Maddie.
Hi, I'm Maddie Little. I'm a junior majoring in robotics engineering technology, and I'm originally from Danvers, Massachusetts.
And then we have Andriana.
Hello, my name is Andriana Onohan. I am a freshman here at Purdue, and I'm studying mechanical engineering technology, and I'm from Cherville, Indiana.
Okay, thank you, Andriana. Okay, let's get started with a question that we hear quite often. We talk about this often because it's very important for us to cover this before we talk about anything going forward. For anybody that's new to Purdue, Professor Burbank, the big question is, what are the differences between engineering technology and engineering?
Thanks, Alex. Yeah, this is a question that we get a lot, and we always enjoy talking about it. So think of it this way. After college, engineering is a profession. And the only differences between ET and engineering exist primarily here in the university. But there's lots of academic paths to the profession of engineering, including engineering technology and engineering, but also majors like physics and chemistry. When I worked in industry, many of the folks I worked with actually were from physics and chemistry, because I was in the semiconductor industry. What makes us unique here in the School of Engineering Technology is not just that our graduates primarily become engineers, but it's the way they're prepared to be successful engineers in industry. Engineering technology emphasizes the industrial application of engineering and science principles, preparing students for work in modern industry. Our courses are application-based, meaning that students learn engineering theory in the lecture part of the class, and then they move to a lab setting to learn how to apply it. About 50% of a student's time or class time is spent in a lab working on industry-grade equipment. It's very much an applied engineering program, and for most of us, especially those that teach in it, this is what makes it the most fun. So, welcome.
Couldn't have been more truer. Professor Newell, since the disciplines are fairly similar, what kind of jobs do engineering technology students see after they graduate?
Yeah, that's really up to the students at the end. So you name a company, and we probably have students that have gone there. So we see students that go to Tesla. We see students that go to Caterpillar. We see students that enter a wide variety of industries, and also even academic positions, and also as well like government related jobs. So some of the national labs have students that go there as well. So it's really up to the person what's the best fit. Kind of playing off what Dr. Burbank mentioned here, I think the biggest difference for our students and what I hear some of my industrial sponsors and industry that works with us coming back and saying is our students are ready at day one. So we have those lab experiences. So I feel like it definitely raises our level of confidence in, getting in there and actually executing, being on the floor, working on something, taking that design to the next level when students actually finish their career at Purdue and start their real profession.
Thank you. That's very true. Professor Hartman, would you please tell us about the major digital enterprise systems and what its unique role within the manufacturing engineering program is?
Sure. Thanks, Alex. Digital enterprise systems is a major at Purdue that's gone through a couple different names over the years, but the primary focus is around how a person creates digital designs of a product and then how they use that information throughout the rest of the organization. So if you've taken classes in high school that might be engineering classes or pre-engineering classes, depending on where you go to school, they might call them something a little bit different. But if you've ever used a 3D CAD system, if you've ever done visualization, or if you've created technical communications like animations or simulations, the students in digital enterprise systems learn how to do that. And that supports a lot of different aspects of manufacturing, everything from the traditional design elements that are part of making and producing a product to how we support the production facility with the digital information that are needed, or that is needed, I should say, for folks like Maddie or Andriana when they do their particular roles in the organization. We tend to be the ones who move digital data through an organization.
Gotcha. Thank you, Professor. Susan, could you also introduce us to the Smart Manufacturing Industrial Informatics major?
Thank you, Alex. So Smart Manufacturing Industrial Informatics is one of the newer majors in our department. We are very much looking forward to graduating the first students with this major next year. The major is designed to focus on the digitization strategies of Industry 4.0 for the systemic utilization of Internet of Things, data and technology in cyber-physical systems with enterprise connectivity. Students will learn how Internet of Things as a system of interrelated computing devices, mechanical and digital machines, when combined with technologies such as artificial intelligence, machine learning, cloud computing, augmented virtual reality, autonomous human robot systems, digital twin, additive manufacturing, and others can achieve new levels of efficiency, productivity, and performance in connected manufacturing systems.
Thank you, Susan. There's a lot that goes on behind the scenes when it comes to the manufacturing industry, a lot of data back there, and it's great for us to have a major to help students understand and interpret that. Professor Garcia Bravo, what makes our mechanical engineering technology major unique, especially when it's compared to the majors in the manufacturing engineering technology program?
That's a great question, Alex. I think in a sense, the MET, the Mechanical Engineering Technology program, is a very traditional type of program, very much like your traditional mechanical engineering. In engineering, the beauty of the MET program is that it's a breadth of a lot of information. You know, like you will see all your fundamental engineering courses that you wouldn't be able to see in a very specifically focused major. So we cover things like heat and mass transfer. We have our traditional fluids. We also have things on statics and dynamics. And so all of the different disciplines that make up for anything that has to do with the classic mechanics is involved in this mechanical engineering technology with a hands-on doing that is traditional to us in the Polytechnic. And so that's what makes us very different in that sense from, say, for example, manufacturing, which is more focused on manufacturing. So if a person was more of a kind of like a holistic type of education oriented, then a mechanical engineering technology program would be more suitable for that person. Say a person that usually doesn't exactly know what kind of field he or she wants to go in at the beginning. Mechanical engineering technology would provide that breadth of like lots of knowledge as opposed to being so focused onto one program. So that to me, it's the beauty of the MET program.
Thank you, Professor. That definitely applies to me, and that's part of the reason I joined. Professor Newell, your background includes the fields of biomedical engineering as well as agricultural and biological engineering. Additionally, you became a professor after working a few years in the industry. How does all your experience come together in teaching the students here at Purdue?
Yeah, definitely. That's a great question, and I definitely have a diverse background. So one thing I would say is I'm definitely an example of multidisciplinary. And the way I see it in engineering technology, we're problem solvers. And it doesn't matter where we solve the problems at. We can solve them in definitely different environments, different settings. And I see the synergy in those applications. It definitely comes through my teaching, especially my industry experience. I also grew up on a farm. We farm now. Those real world experiences really pull like the theoretical physics concepts that we learn here into play in the real world for me. I definitely think those experiences are translated into the examples I give in class, the homework assignments, the projects that we do.
Gotcha. Thank you. Professor Fuerst, may you please, I'd ask you to talk about your experiences. You spent more than 13 years working at Boeing and 21 years in the U.S. Army Reserve. How does your extensive industry experience influence the way that you work with students?
Happy to answer that. Well, being out in industry after leaving Purdue in circa 2000 2002, I'm on about my fourth career as I see it. I started out with a software company that works in PLM, product lifecycle management, that being Dassault Systems. That's the software that Boeing uses to build the aircraft like 787, 747s, all the new aircraft they're building now. And then I had the opportunity to work for Boeing after being there as an expert, paralleling that with a military career at the same time. Being on those programs in a role where I was an instructor. I was essentially in the learning and training and development organization, and I got to teach engineers about the tools and the processes they were using. You know, they knew how to engineer. They didn't necessarily know how to use these new tools and processes that came about around the turn of the century here. And then my background as I was a drill sergeant. You know, I got to yell at privates and stuff, and make them do push-ups and stuff. I don't do that here. I kind of given that up. However, I got to run basic training, work with youth along the way. I like to teach. In my lectures, I tell a lot of stories. I mean, that's, I give you the meat, what you need, wrapped in a package of a story, based on my experience, what I've done in time. I've been to Paris. I've been, with work. I've been to Tokyo. I've taught many different folks in many different countries about what I know about digital enterprise systems, change and configuration management, because the only constant is change. So teaching that and conveying that to students, like, you're going to have to deal with change. And when you step foot on campus, things are going to change right away. From your high school to campus, and first semester to second semester, in the middle of the semester, just expect change. And one of my tenets is I really like to give you my experience, give you the inside scoop on what you're going to experience. So it's not when you see it or you run into it, you're like, oh wait, Professor Fuerst mentioned that, and you get over that a lot faster. Okay, I want you to get where I got a heck of a lot faster, and so you can move further in your career. So,
Gotcha. Thank you, Professor. I also have a question for Andriana, transitioning over to the students. Could you please tell us about your high school background and how it got you to thinking about technology and engineering, and also why you chose to come to Purdue to study mechanical engineering technology?
Yeah, of course. So, my experience is a little different. I did not know I wanted to do engineering until about my senior year. I wasn't really introduced to engineering. All I knew was that I loved math and I like to build things. So when my counselor recommended a Project Lead the Way class, I got put into that and I absolutely loved it. We did a lot of things that, valued engineering concepts, and we did CAD stuff. And so that really sparked my interest for it and made me want to continue in college to do it. So when it came down to thinking about colleges, Purdue just really stood out due to its program that they have, and specifically the Polytech, because of the hands-on experience that it can give you. You get a really tailor-made learning experience, and I really enjoyed that. And I really I learned better more applicationally. And, the technology side of Purdue and the Polytech really allows you to apply what you're learning through labs and different things. And so that was a huge reason why I chose Purdue.
Thank you, Andriana. Maddie, I got a similar question for you in the robotics engineering program.
Yeah, so I first got into robotics in elementary school. I did a Lego robotics camp over the summer, and I was just able to learn a lot about basic robotics through that. And ever since then, I have thought robotics was really interesting. I picked Purdue because it was the only school that I applied to that actually had a robotics program. And it was a plus that it was a applied learning degree, so I could actually learn more hands-on things like I did in that camp. But in addition to the program, I also picked Purdue because I'm in the marching band. I did marching band in high school, and I really wanted to participate in a collegiate marching band after high school.
Thanks, Maddie. It's nice to hear about the life outside of just the educational curriculum as well. I have a story somewhat similar to Andriana. It kind of started back with Legos as a kid and whatnot, and then it kind of progressed as I progressed throughout in age, I would say. So then it started tinkering with broken radios and stuff around the house, just understanding how things work and how they went together. And it ultimately ended in like working on my first car. I ultimately enjoyed every moment of it. I found passion in the curiosity and understanding like the way they were designed and intended to be used, as well as the engineering behind all of it. And after a bit of research, I found out that I kind of wanted to do mechanical engineering. It was a little more broader. I knew I could like kind of focus it later on And then I did a little bit more research and found that I had a great engineering school in my backyard. So I made the drive up to West Lafayette, and so far it's paid off. The mechanical engineering program has been great for me, especially for the first couple years to be a quick jump into actually doing that hands-on learning, the applied learning that some of the other mechanical engineering programs, such as the College of Engineering, don't necessarily get to experience. And so it's been a great decision for me, and it's paid off so far. Ken, I'd like to transition to you. Could you tell us about the could you tell us a little bit more about Dudley and Lambertus, the new building that was built in January 2023, and then some of the labs that the students will use over the course of their educational career here at Purdue?
Sure, I'd be happy to. So by now you've heard us use the word labs and application and hands-on, just about every one of us every 2 minutes. And so that means we have labs. In fact, we have labs in, I think, 5 buildings on this campus. The newest one being the Dudley and Lambertus halls, which are, we're in a close space here to the Conoy building. That building in total is about 250,000 square feet. We do share it with the College of Engineering, and it's primarily a lab building for both colleges. Our school, the School of Engineering Technology, has more than 20 labs in that one building alone. So our capstone lab is in that building. Our mechatronics and robotics labs are in that building. And one of the campus favorites, the guitar lab, is also in that building. So you may get a chance to build a guitar at some point. More importantly is our smart manufacturing labs. So we have a learning factory in that building, another lab focused on the industrial Internet of Things, and in the basement we actually have a smart foundry where we actually pour molten aluminum into molds. So this is a very unique collection of equipment. These labs are interconnected. I think when Dr. Hockings was talking about the smart manufacturing major, you heard all the different elements involved in a manufacturing process that includes intelligence. And so these labs are built with that in mind. So they're interconnected both in the data and in function. So it is very much an integrated learning environment, and it is so unique that we have constant stream of industries and universities coming to look at it to see how we've pulled this off. So when you get a chance, you need to come and look at it too.
That's definitely true. That building has been a blessing, and it's kind of like a cool place to walk through every now and then. Professor Hartman, could you elaborate on how students in manufacturing and mechanical engineering programs have a variety of opportunities for applied learning and real-world experiences?
Sure can. It's interesting that you asked me that particular question, only because as everybody's been talking, I've been thinking about all the different kinds of things that we see on a day-to-day basis that might somehow engage students, not just in hands-on learning, but in learning in an environment that is industry engaged. Professor Burbank just mentioned the laboratories, the new ones in particular, that are in Dudley and Lambertus halls. There are not, well, let me say it this way. There are many of our labs that are outfitted with equipment that is less than 5 years old. And so one of the things that you're going to see when you come here is things that are still state of the art, state of the practice, and you'll learn on machines that you may very well see when you leave Purdue and go to work. It may not be the exact same brand, but you'll certainly see the types of machines. As far as uh, other opportunities for work or for student research and the like, there are plenty. I can say with certainty, Professor Fuerst, Professor Newell, Professor Garcia Bravo, myself, we all hire students, whether they be graduate students or undergraduate students. In fact, I have two undergraduate students working for me now in my research lab, one of whom is in MET, the other is actually in computer science, and they're working on machine learning algorithms and machine vision algorithms for quality control and inspection in a manufacturing environment, and how we use that digital data in the kinds of systems that Professor Fuerst and Professor Newell mentioned as a way to close the loop, if you will, to see whether or not we've made products correctly. And the one student who is an MET student, he is in fact going to stay and start graduate school this summer. And so, I would encourage anybody who's listening tonight that if you do have an interest in working a little farther, maybe even a little deeper into a particular subject, that often many of us have funding from a variety of different sources for research or even part-time jobs for students while they are here. And certainly working in one of these laboratories, whether you are an undergraduate student or a graduate student, is a great way to get experience. And so I would certainly encourage those of you listening to think about that as a possible alternative.
Thank you, Professor Hartman. Susan, I'll turn it to you. There's more often men in engineering roles and education as well than women in the STEM fields. Why do you think Purdue is the right place for both women and men who want to be in engineering and technology?
Thank you, Alex. You probably didn't know this, but that is actually a topic that is very near and dear to my heart. I do have an advanced degree in a science field. So supporting women in STEM education is very important to me. I love being able to work with our students and help them progress and see them grow and blossom as they go out into industry. We do have a large group of women faculty members in this department, and we also have a lot of women graduate students who are going to be teaching assistants for our undergraduate students. So the School of Engineering Technology is a great place to be a woman pursuing a STEM education.
Couldn't be more true. Maddie, what has your experience been like as a young woman in the robotics engineering program?
Purdue is super inclusive and treats everyone equally. Professors just see everyone as students and future engineers, so it's really nice to be around people who don't seem to discriminate against women. And it's also really good to be at Purdue because there's a lot of good communities for women in technology. There's a club called Women in Technology, or WIT, that I'm a part of, and it's a really good way to meet other people that are going through the same things that you are. And freshman year, I was in the living learning community for that organization, and I was able to meet some of my very close friends through that because we lived in the same dorm and we were taking the same classes. So overall, Purdue is really great for women in STEM.
It's great to build that sense of community, especially early on. Andriana, do you have anything you'd also like to add as far as the welcoming and supportive nature of Purdue?
Yeah, kind of building off of what Maddie said. I mean, I also joined Women in Tech, which was a great experience. You build a lot of connections through that. And just as far as in class and in labs, I feel like I'm very accepted. There's no bias or judgment, whether being a woman or a man. So it's just a very welcoming environment. There's no restrictions placed on me. And overall, it's pretty fair for everybody. And I really love that.
True. Okay. Can we talk a little bit more about the actual plans of study, Susan? How are the various majors in the manufacturing and mechanical engineering programs similar, and how do they differ a little bit?
They are fairly different at this point in time. There is not a whole lot of overlap between all the 6 majors that we're talking about tonight. All of the majors in the School of Engineering Technology do take the gateway class that Professor Newell teaches. They all take a programming class. Some of them might take slightly different programming classes, and they will all culminate in a year-long capstone sequence where you're most likely going to be on a team with students in the different majors in the department. In between that first year gateway class and the senior year capstone, the focus is going to be very different for the 6 different majors that we're talking about tonight. Mechanical engineering technology is going to go through a lot of the courses that Professor Garcia was talking about. You're going to have statics, you're going to have thermodynamics, you're going to have fluid power. The different, some of the manufacturing majors, automation and systems integration, and mechatronics and robotics are going to bring in more electrical classes. So you're going to have a combination of mechanical engineering technology classes, electrical engineering technology classes, and manufacturing classes. Maddie's probably taken all of these at this point in her robotics major. So you get to combine all the aspects of our department together. Digital enterprise systems and smart manufacturing informatics. They draw on the core courses for mechanical engineering technology and manufacturing engineering technology, but then they very much have a focused set of classes that is specific to the major.
Thank you, Susan. Professor Garcia Bravo, when do you think the courses start to get more specialized with regards to the student's intended major?
Yeah, so for most of all of our programs, really, we start with very similar type of classes, like it was mentioned before, with Professor Newell's class. Every major comes in and they are learning very much the same fundamentals. As you progress, I think probably even in the second year, that's when you start like getting deeper into your area of specialization. By the third year, you're already taking some advanced classes, like the one that I teach is at advanced fluid power. And so for those who are really interested in systems that are integrated and how those systems are put together and how they are sized according to the need of the machine. Those happen in the third year. By the fourth year, you should have received a lot of the not only the fundamentals but also the specifics of how to put together those systems so that you can do them on your own and you can design your own system. So it's a progression. I can speak very I think I have experience with the MET program the most. For example, in MET, you start, of course, with the general class, but also in your physics and your math, but also you get the fundamentals of materials and also some of your graphic design classes. So everything, it starts from elements and then it grows into systems when we start looking at heat and heat and mass transfer, and then fluids and things like statics, and all these things start compounding from the component level to the system level, and then it grows into designing and building your own things. And so I think that there is that progression. Definitely, to answer to your question succinctly, I think it's by the third and fourth year when you're really digging deep into your area of specialization, whether it's manufacturing, mechanical, electrical, whatever it is that you're doing. That's when you're really getting into the details.
Okay, thank you, Professor. Speaking of getting into the details of things, we actually have a student that's actually had an industry experience. Maddie, could you kind of elaborate on what you kind of saw in the world?
Yeah, last summer I had the opportunity to be a manufacturing engineering intern at Gorton Seafood. And my overall role was kind of just problem solving. It's a food manufacturing company, so they produce different types of fried seafood products. And so I had the opportunity to kind of work on each of their lines and see where there might be bottlenecks and just overall inefficiencies. So me and my supervisor went through all the lines and tried to find places where I could either create a new part or think of some other way to process the packaging or the actual food product to go through the line quicker so they could produce more packages at a time and overall increasing their income. But I learned a lot about CAD modeling and ladder logic, which has played into my classes. At Purdue, I've taken a CAD class and a PLC class, which have include both ladder logic and CAD. So it's been very helpful for going back and forth between internship and school, just taking my knowledge from both sides.
We also have a question from one of the viewers. Ram was asking, what sort of projects or labs have you seen relating to building robots so far?
I haven't had the opportunity to actually build a robot yet, but one of the classes I have taken is programming industrial grade robots. So my sophomore year, I took an intro to industrial robots class where you work with FANUC and Yamaha robots, and you learn the different programming languages for those. And at the end, you get to do a final project and kind of just make the robot arm do a certain task that you want. So for example, my group, we made an M for MFET. We had the robot pick up a pencil and draw it down on the piece of paper in front of it, and actually draw out the M. So that was really cool.
Thanks, Maddie, for speaking on your experience. I want to slightly transition to the professor side. Professor Hartman, could you speak about why it's important for us students to get that industry experience?
Well, because all the cool kids do it. No, no, I'm just kidding. It's really important, I think, for a couple different reasons. One is that even though it's going to seem like a long time when you're here, you are actually with all of us for a rather short period of time. 4 years is not that long. And so there are many things that you will learn about how to integrate the kinds of things, whether they be technical or not, that we are teaching you all in the classroom. You're going to learn a lot about how to interact with people, differently than the way you would learn to interact with them or in sort of a school environment. Thirdly, it gives you really a good opportunity to see both what you would like to do and possibly what you might not like to do when you graduate and go off to find that first job. So I think there's a lot of benefits to work experience for sure. It also gives you a chance to learn some new skills, maybe to flex some existing skills, and really get a sense to kind of see what you're made of. I think all of us who are professors on the call this evening, I think all of us could probably, well, we could use all of our fingers and all of our toes probably and run out of digits to count the number of students that we've sent off to work experience before they've graduated. And I promise you, I'm not stretching that number. I think all of us is multiple. And so that is one thing I think that you're going to find here at Purdue that, I mean, it goes on in other places too, don't get me wrong, but I do think that our students benefit a lot from getting internships or even work experience while they're going to school very early in their studies. I would highly encourage all of you who are listening tonight to, if you end up joining us here at Purdue, or even if you don't, start looking and start really applying towards internships and other work experience right after that first year. It's an important thing to do.
Right. And that also makes you a better candidate, but it also helps you focus like what you want to intend to do outside of school. Professor Garcia Bravo, do you have anything that you'd like to add about experiences?
Most definitely. Another aspect here is that there is a great number of our research projects that are sponsored by industry and are very hands-on and very applied research. We're developing products, if you will, or processes for companies. And so not only you get to do that, in your summertime, but also in the context of uh, your time at Purdue as a student. And so I do think that the earlier that you start, the better it will be, because you will get more chances to try different things. Say, for example, you might try the automotive industry in 1 year. You may move to aerospace in the next, maybe food industry if you want to try that. There is so many companies out there that are coming to Purdue to get our students. The possibilities are endless, and so I would really encourage any student, like Professor Hartman was saying, any student, whether they come to Purdue or not, to try out as many options to get those internships.
Thank you. Professor Fuerst, do you also have something you'd like to add?
Sure. What I would say, you're going to find that your classroom instruction, you're going to be able to take that straight into an internship and apply it right away. I've gotten emails back from students after, taking one of my courses. I teach one of the larger, what students would call a CAD course. It's more of a product design and design for change course. So taking what you may have done in high school, done a little modeling, gotten into Tinkercad or maybe SolidWorks or Fusion. What I like to do is take it to the next level. You're going to model, you're going to create models that you actually program and that you can quickly change and morph. And then you're going to use that in a context of a PDM system. You may have never heard of a PDM system. You probably don't even know how to spell PDM system, but that's a product data management tool. That's what industry uses to manage data. When you're talking about an aircraft, a 787, for example, you're talking about 2.3 million parts. So you get a taste of that because you're going to use in these classrooms, you're going to use those industry applications. So when you go out into that internship or that first job, typically at any other university, and they're not using these tools. They're not using the tools to the extent we use them in the classroom. And I've gotten emails back from students that have gone to their first internship and said, "Oh my goodness, we're doing exactly what you said we were going to do. I didn't believe you then, and I believe you now." And that's one of the first emails I throw up now in the classroom. Pay attention, because this is where we're going. You can hate me now. I go for the delayed gratitude. I just wait for a couple of semesters. So you're going to get that experience. You might not believe us when we're telling you, but when you get out there, it's going to hit you. And hopefully it's not, and our goal is it's not the first time you hear about it or you see it. You're ready to run with
it? Very true. Professor Garcia was briefly talking about research opportunities for undergraduate students. Professor Newell, do you have anything you'd like to add?
Sure. I think all of these opportunities, whether they're industrial experiences or research experiences on campus, are all really important in building your resume and understanding what you like and what you don't like. I do a lot of undergraduate research experiences. I have 7 undergrads right now, and then I also have a team of about 30 undergraduate students who are working on a competition boat. And these students, they're doing a variety of things. Some are 3D printing flexible sensors for bio applications, whereas others are actually getting ready to compete in a program from the Naval Surface Warfare Center, and they've built an autonomous boat. So we have to navigate using artificial intelligence through a series of challenges, and we compete with 6 universities around Indiana for this challenge. So I think these experiences, they allow students, for one, to get into the lab, get to know other people. They're mentored by graduate students and myself, but also they add to the resume and allow you to try out different things, right? I've had students, we've been doing this competition this is the 2nd year. Some started on one team, like mechatronics, for example. And then they also wanted to learn something about computer vision. So then they switched the next year. So I think it allows you to test the waters, and also gain real world experiences before you finish up here and move on to your full profession.
Thanks, Professor Newell. Slightly transitioning a little bit, Professor Burbank, could you elaborate on what exactly a senior capstone project is? I know that's a requirement for us Purdue students.
Certainly, Alex. So it's a requirement for students in our college, not across campus. But for engineering technology, our students are required to take a two-semester senior capstone sequence. And basically, that allows you to work on a project that puts all your prior learning in one place at one time. The other really fascinating part of these projects is that many of them come from industry. So we have a team of faculty that work with industry to define projects that a team of students can work on over the course of 2 semesters. Most of these teams are interdisciplinary because most of the problems nowadays are interdisciplinary. But these are real world problems. The companies want an answer. It is a class, so you don't fail if the rocket doesn't hit the moon. But it is a real world problem, and the companies are there. And to the point where they provide a mentor that works with these teams. So it's quite serious. There are other projects, and I know Dr. Garcia and I think Dr. Newell as well sponsor capstone teams on projects that further their research or some other entrepreneurial project that they're working on. So it's very much a tight environment. We have a lot of space and resources allocated to this, and it certainly is a time for students to shine. It is not uncommon for companies to come in and hire students after working on these projects. So it's good. Very nice experience.
It is. I like to kind of call it an in-house internship. Gets you kind of exposed to those industry projects as well as working with different majors and different backgrounds and kind of communicating yourself well. Professor Hartman, could you also expand on the benefits of industry-sponsored student projects?
Absolutely. I think the best anecdote I can give you is one that stretched over probably a period of about 8 or 9 years that started with it actually was somewhat early on in my career. I was working with Rolls-Royce in Indianapolis, which if you don't know, they make aircraft engines at that facility. And the what started off as a very small, very compartmentalized summer research project, it turned into 3 different capstone courses, projects over the years, which led to 2 master's theses, 1 PhD dissertation, about 6 graduate students, and 2 full-time hires at Rolls-Royce when it was all said and done. And I think that is probably my best story I could tell you about what some of those things can turn into. But to my other faculty colleagues that are on the call tonight, I would echo their sentiments in saying that many of these capstone projects turn into job offers for students, and because those companies typically bring to us some kind of a problem that I'll say it needs to be solved. It may or may not be urgent for them to solve it, but it needs to be solved at some point for their business. And in many cases, it is not something that they either have the time or the exact resources to solve at the moment. And so it is definitely one of those proverbial win-win situations for both the students and the faculty involved as well as the company.
Thanks, Professor Hartman. I'd like to transition to a common question that many future students ask. They ask mainly, what type of computer should I need going into an engineering program? And I'd like to answer with the fact that I commonly use a Lenovo IdeaPad, as opposed to the ThinkPad. It's a little bit more consumer based, but it's helped me well throughout my 3 years here, and it's done good. I've seen certain students get away with using MacBooks. I mean, not Macs, yeah, but MacBooks. Um, but it should work. But if you guys also don't have access to getting those computers, there are dozens of libraries across campus. as well as hundreds of computers that should have the software that you need. And if not, there's also a way to get them remotely to your personal laptop. And so those opportunities are not few and far between as far as your progression throughout school. Susan, do you have anything you'd like to add as far as laptop accessibility?
Alex, I would agree with what you've said. In general, if you have a computer that works, I would probably bring it with you to Purdue and then see what your needs are later on. If you are truly looking to buy something new and you are not already familiar with a system, in our area, I probably would recommend a Windows PC. There are dyed-in-the-wool Mac people, and they are not going to change, and I'm not going to try to change them. But most of the programs in our department do work better with Windows-based systems.
And Professor Fuerst, do you have anything you'd like to add?
Yes, I can speak to that because we just updated the computer recommendations for SOET. And if you search SOET computer recommendations in Google, it'll come up. It's right there. You're going to need a PC. Macs I do not recommend a Mac. We don't really support Macs in the department. It's engineering applications don't run on Macs. They don't run very well. One of the first courses I teach and Professor Newell teaches, it's CAD. You're going to need a good graphics card. You're going to need some RAM to get that done. What I like to tell students is a good gaming computer, and parents probably hate this, a good gaming computer will probably do you well. If you look at the recommendations there on the website, though, it'll going to give you more specifications. About 32 megs of RAM at the minimum. A good, decent NVIDIA graphics card, and probably like an i7 processor or something to that effect. All right, so stay away from Macs as much as possible.
Thank you, Professor Fuerst. Transitioning and starting to wrap up here, I'd like to ask each of the professors a question as far as advice they'd like to share for future students to both be happy and successful here during their time at Purdue. Professor Burbank, you're first.
This is a good question to be first on. So one of the things that I want to point out is that here in the School of Engineering Technology, we have a motto, which is students first in all we do. And this is something that all of us, faculty, staff, and even the students, I think, realize that we really are serious about this. This is about your success, and that's why we're here. That is why this university exists. That's why this school exists. That's why we work in these jobs, is for your success. So don't forget that, and don't hesitate ever to call on us, faculty or the advisors, if you need any help.
Thank you, Professor Burbank. Same question for you, Professor Newell. How can they set themselves up for success here?
I think something that's kind of important is to set yourself up with a plan. So we have a lot of opportunities here at Purdue. We have tons of clubs. We've got research opportunities. We've got the industry connections that we've talked about. So there's lots and lots of options. And I think honing in on what interests you, because you do have this wonderful 4-year timeline where you can try out some of these things. So doing a little research up front, finding what you're interested in, and then finding your niche, like finding your area and people to surround yourself with that will help you to be successful.
Thank you. Professor Fuerst, do you have any advice for future students?
Yeah, what I would tell you, come ready to work. There's a lot of opportunities to play and to do the fun things, because you're not going to be managed. Nobody's going to tell you what to do, when to do it. You're going to wake up, you may not have classes, and it's your choice to do nothing or work towards learning something that day. So what I like to say is eat the frog first. Do that thing you don't want to do, get it out of the way, get it done. And then once you start on it, focus and finish, just get it done. Spend the time in it. If you've got downtime or free time, do it. I remember being, in college, video games were the big thing. And in between classes, I'm playing video games. I'm playing Crazy Taxi at the time, whatever. But at the same time, I was getting my work done ahead of time before it was due. And that's the other thing. Don't wait until the deadline, the day of, to start the work, because you're going to find out it was a lot more work than you thought it was going to be. And then you're going to ask for an extension. And extensions are the deadline minus 2 weeks, and there's your extension. So you got a backward plan to get that extension. So yeah, not a lot of extensions come out of there. So yeah, focus and finish and work ahead as much as possible.
Definitely true. It's better to keep yourself swimming before you drown. Professor Hartman, do you have anything you'd like to add as far as success at Purdue?
Can you tell Professor Fuerst was a drill sergeant at one point?
Yeah.
It's funny, I guess. So this is my 22nd year at Purdue. I would say maybe the three nuggets of advice I typically give my students are, first of all, invest the effort. I think to Professor Fuerst's point, it is work. We don't give it away. So, invest the effort in what you're doing. Secondly is be opportunistic. I don't mean that necessarily in a way that takes advantage of people. I mean it in a way of take the opportunity presented to you. It might be scary. A lot of hard things are scary, but also a lot of worthwhile things are scary in the very beginning. And so take the opportunity when it gets presented to you and be opportunistic. And then basically the third thing is don't suck. And from that perspective, I mean, be good at what you do, right? Start day one and want to be good at it. That is probably the best thing I can tell you is, so invest the effort, be opportunistic, and don't suck.
Thank you, Professor Hartman. Professor Garcia Bravo, would you have any words of wisdom?
Thanks, Alex. I couldn't agree more with all of my colleagues. I would add that if you are able to create some habits to be able to complete your work on time and be the best at what you do, I think habits like, for example, treating schoolwork as work, like making sure that you're showing up to classes and that you are present when you are working with your colleagues, like for a lot of the projects that we do are in groups. And so making sure that you're present for those. I recommend, as a rule of thumb, if you make it a priority to be in school from 8 to 5, like a regular job, you're very highly likely to do well because you're always doing something. You're spending your time wisely as opposed to, like fooling around and wasting time like I did when I was in college. And so I think that's number one. Number two is surround yourself with good people. Try to find people with same values as you. Try to find people that are worth imitating, whether they are a little higher like further ahead than you are, or maybe they are at the same in the same stage that you are. But try to find people that are like good students to help you and study with you as you have these homework assignments and studying for exams. It's much more fun when you do it with friends than when you do it alone. Those are my two pearls of wisdom.
Great point to mention, Professor. Even just being in the room is way better than being anywhere else. Like it just sticks a little bit better. As far as keeping yourself ahead, it is giving you more time to have fun on the weekends and actually have that time. So just put your work first. Susan, do you have anything that you'd like to ask?
I'm going to add two things to what my colleagues have already said. Your schedule is going to look very different when you get to Purdue than it was in high school. You're not going to have a school bus to get you to school in the morning. You're not going to have bells making sure you're going to the right classes. The first bit of advice is go to class. You are going to get a lot of information just by going to class. And then, follow up with all the assignments the way the professors have said. The other thing I'm going to say is that there are also lots of opportunities for support at Purdue. And we are happy to help you. Your professors are happy to meet with you. Your advisors are happy to point you towards resources in the department, in the college, in the university. But we don't know if you need them if you don't tell us. So please feel comfortable talking to your advisor and your professors and letting them know what you need.
Mm-hmm. Reaching out for help has never hurt anybody. Jumping back to the student perspective, Andriana, do you have anything you'd like to add?
Yes. So all these professors are very right. From the student perspective, that would be my best advice, is to set yourself up for success by being organized. The thing that helped me the most was, writing down everything that I had to do each week, and, making sure I had all my classes mapped out and what times I have to do this, and, setting my schedule ahead of time so that way I can relieve some stress and anxiety about, things that I don't know what's coming yet. So definitely do that. And that allows for you to time manage better and also get all your work in that you need to do. But overall, that has definitely been the best. And again, like some have said, is showing up to class for sure. I think that's one of the most important things, is like showing up to class already gives you a better advantage because you're not behind on anything. You're always present and you're always there. So I would definitely say that's my advice.
Thank you, Andriana. And Maddie, do you have a quick word that you'd like to add?
Yeah, I think it's important when you get to Purdue. It's a big place, so it's important to try to find a small group of people that you're friends with, whether that's joining clubs or band or frats or sororities, ROTC, anything like that. I know I'm a part of marching band and some other clubs. I'm in a robotics club that you get to build robots in, and that's awesome that I get to do that outside of class. And like everyone else has also said, time management is super important. You want to have a good school life balance so you don't burn yourself out too quickly and get bored of your assignments and classes before your 4 years are up. It's good to plan ahead so you actually have free time and you can hang out with your friends and go experience college outside of the classroom. I think it's really great to try new things. If you are on campus, I really would recommend going to Lawson. They have butterbeer if you're a Harry Potter fan. That's always fun. But there's a lot of fun things just on campus outside of school that it's good to get yourself out there is really important.
Thanks, Maddie. A little advice that I'd like to add is kind of a culmination of what was all said. Yeah, being present definitely helps. It allows information to stick. Staying on top of your work and not allowing it to pile up, it's just better for your mental as far as, and then producing quality work as well. It kind of helps with that. And then having a good network system that pushes you to that motivates you to be better and like actually understand what you're doing, not just mindlessly do the work. That's ultimately proven to be a key factor for most of my success here. And I'm looking forward to carrying that as I eventually go on to graduate. But thank you, everyone. That mainly concludes our broadcast for the evening. And we hope that you guys learned something new about the School of Engineering Technology at Purdue. And we thank you guys for watching. Please join us for one or more of our upcoming events for the admitted students, including a Purdue for Me, which is an opportunity to visit the campus with your family. There are also many online information sessions, student to student chats, and parent and family chats. You can find the information for all of those opportunities on our admitted students information page. And then also, I want to say thanks again for all of our panelists joining us and sharing your wisdom and experience. And if you joined us late, please be sure to watch the replay because we talked about a variety of topics during the last hour. Thanks to John, our technical director, doing all the behind the scenes work, as well as Diane Razel, who helped us answer questions in the chat room. As mentioned before, please feel free to send an email to techrecruit@purdue.edu if you guys have any additional questions for us about the engineering technology program here at Purdue. And just a quick reminder, the deadline to accept your offer is May 1st, 2025. So thanks again for being here tonight, and have a great evening, and boiler up.